All right, so that's not our last topic. We have two more topics to go. Our second to last topic is looking at respiratory volumes and capacity. So these are essentially measurements of the volumes of air that we breathe in and out of our lungs. And these can be really useful because what we want to have a general sense of is what are the normal values. And that way, when something goes abnormal, it's obvious that it's abnormal to you. So, a lot of numbers here, a little bit of math, but pretty simple stuff. So, first thing to understand are these first few terms. They are worded like tidal volume, but they're also abbreviated TV. These can just be nice. It makes it more efficient to be able to think about them in your own head or write them out by hand. But it's important when you're first learning something like this to make sure you're saying the whole word because these words are really useful. They tell you a good majority of what the heck it means. So they sort of are self-defining terms, which is nice. The last term is spirometry, or spirometer, which is an instrument used to measure these volumes. And so, really, you could think of as this topic as spirometry, the measurement of volumes for breathing. And so let's move on to these first few terms here: tidal volume, inspiratory, expiratory, reserve volume, and total lung capacity. So we've got two pictures that illustrate this. The first one's sort of an introductory picture here. I keep these both here because some of these pictures resonate more with some people, and the second picture, some people understand more. I personally like the second picture a little bit more, but both are good. So let's start with the top one, though, and what the value of how this is illustrated. Basically, this has all of our capacities and volumes here that we're going to cover in this entire list. It has them all in here, which is nice, and it has them color coded. But before you start reading these, what we have to get familiar with is what the heck is this? So this is a chart that has two measurements on it. The first one on the x-axis down here, the bottom line, this is just time. So this is moving through time from left to right. And so the only one that's actually measured here in some other unit is milliliters. And milliliters are the volume of air moving in or out of your lungs. And so notice the top here is 6,000 milliliters, which is the same as 6 liters. So if you imagine 3 2-liter pop bottles, that's basically the maximum volume we're dealing with here. And that would be somebody that's young and probably fairly tall, would have some kind of a volume up around 6,000 milliliters, or if you want to visualize it a little bit easier, 3 2-liter pop bottles would be 6 liters. Same thing on this bottom chart. It's the same exact thing, same units, milliliters, so they're always going to be in thousands or hundreds. And they are basically talking about breathing. So let's go through these kind of from beginning to end. Let's start with tidal volume. Tidal volume is the volume that you will breathe or exchange both in and out during a normal breath. So when you take a nice gentle breath in, it's right around 500 milliliters. That's the air moving in. So if you look at my mouse going up, it's a little 500 milliliter increase. And notice on the chart here, 2,000, 3,000, the difference is 1,000. And notice that this is half of that 1,000, so that's 500 in and 500 out. So that's that normal breathing. And so tidal volume is just kind of our regular resting breathing rate. It's not very much. We're barely using the volume of our lungs when we're at rest. Then sometimes, though, as we know, we need to take a big breath in. And so the first 500 milliliters of, let's say you're sitting here and you've breathed out that 500 milliliters, and now you take a big maximum breath in, as much as you could possibly fill into your lungs, all the way up to as high as you could go. Let's say it's 6,000 milliliters. That would be pretty impressive. So you've got all that air in your lungs, and now you let the air out. All the way back out to the bottom of your normal breath. So that's what that big arc is representing. So tidal volume is actually the first 500 of that maximum breath in. If you started from your exhalation, that gentle breath out. So that everything beyond your normal 500 milliliters that you would normally breathe in, everything beyond that you are breathing in or inspiring, that's your inspiratory reserve volume. This is a big volume. Inspiratory reserve is usually like 3,000 milliliters in a nice healthy person. So it is our biggest single volume. And 3,100 is sort of the reference value that your lab textbook gives you. Some people get confused though because we go up around 3,000. So if you count your way up, there's a little bit of color there. So there's that 100 milliliters is just that very little sliver of peach. And then 1,000, 2,000, 3,000, all the way up to 6,000, plus that 100. So that's where they get that 3,100. You don't count the volume that you breathe in and breathe out. If you were to count both of those, it would be 6,200. In practice, this is actually pretty important because the way a spirometer works is that you instruct somebody to do something like take a big breath in and you measure it. If you keep the spirometer on their mouth when they breathe out, you may double the measurement. You might actually get double what the actual inspiratory reserve would be. Now, if you're using a digital one, usually they can sense the direction of airflow, so you can kind of be a moron when you're using it and still get the right number. But that's the important part. And in this class, the important part is the definitional understanding of this. So what that means is that what the heck is inspiratory reserve volume? It is the amount of air beyond your tidal volume that you can breathe into your lungs. So that right there, essentially. It does not include the tidal volume. That's why there's two different colors here. So then, you know, obviously you can breathe out pretty impressively too, not nearly as much as your inspiratory reserve, but you also have what's called your expiratory reserve volume, which is exactly the opposite of the inspiratory reserve volume. So if you are taking your natural, normal breath out, that little 500 milliliter puff, anything beyond that you're capable of breathing out, that's your expiratory reserve volume. Our reference number here is 1,200 milliliters. That's a good average, but I do want you to know these rough numbers. If you miss them by 100 or 200 milliliters, I'm not going to mark you wrong. It'll be sort of loose. But what is most important actually, like when you walk away from this class, is to understand that inspiratory reserve and expiratory reserve are really different from each other. And your ability to breathe in is about twice your ability to breathe out in terms of volume. And for those of you wondering why that's the case, why isn't this symmetrical? Well, we evolved from diving mammals, and we ourselves actually needed the ability to hold our breath. And when you hold your breath, it's the inspiratory reserve that matters. You take in as much air as possible and you take it down with you below the water. Expiratory, you're actually not very good if you can breathe out a ton of air. What you want to be able to do is breathe out rapidly, because that's what happens when you run out of breath, right? You go sprinting. It's your ability to rapidly, it's your expiratory reserve frequency that matters the most for breathing out. Inspiratory reserve is really for diving. So that's why there's that asymmetry there. And then the last one here is a residual volume. Residual volume is listed down here as a 1,200 milliliters. And 1,200 milliliters is left in your lungs after you try to breathe out as much as you possibly can, because you cannot flatten your lungs maximally. There's always going to be some amount of air left in there. So that's your residual volume. It's the air that's sort of trapped in your lungs. So I like this picture as an introduction. If we go down here, you can get all of these volumes that we're going to continue to talk about. And these are sort of broken out to the side. The reason they're out to the side is that we've been talking about volumes, residual volume, reserve volume, inspiratory reserve volume. They're all volumes. Volumes are the fundamental pieces of spirometry. But then when you add volumes together, you get what are called capacities. So when you hear that term capacity, it's always the combination of multiple volumes. For example, the inspiratory capacity is the combination of the tidal volume and the inspiratory reserve volume. So when you add these two together, you get the inspiratory capacity. And so the definition for inspiratory capacity would be the maximum amount of air that you can breathe into the lungs. Whereas the inspiratory reserve volume is the amount of air that you can breathe into your lungs after you've already breathed in your tidal volume. So there's sort of just that mathematical relationship. Inspiratory reserve plus tidal volume equals inspiratory capacity. And then we also have another term here called functional residual capacity. And if you look at the purple color, it's basically everything below the tidal volume. It does not include the tidal volume, I guess is the big thing to remember. It is everything below this graph on it's all the volumes below the tidal volume essentially in the chart. So expiratory reserve plus residual volume equals functional residual capacity. And then we have this other term, which is a really important one. This is called vital capacity. Vital capacity, if you look at the gray here and you follow it over, it's these three terms, inspiratory reserve plus tidal volume plus expiratory reserve. Those three combined are called vital capacity. That's the most fun one to measure. That's the one where you basically take a giant breath in as much as you possibly can. You get up here in the chart, and then you could put a spirometer on your mouth and you go, then you blow out as much as you possibly can. And that would give you that peak to peak, maximum top peak to bottom peak. That's the vital capacity. And then the last one here is total lung capacity. So total lung capacity is all of these added together. And so you can see you've got the kind of the formula written out here. Total lung capacity is all of those volumes added together. Those 4 volumes added together would be total lung capacity. Total lung capacity is not one that you're actually going to measure clinically, though. So this is a very difficult thing to measure, residual volume. You can't breathe this out, so you can't measure it through spirometry. So this number is essentially average. So from an actual measurement perspective, what you would be measuring is vital capacity or any component of vital capacity. So inspiratory capacity, you could measure that. You could measure inspiratory reserve volume, tidal volume, and expiratory reserve volume, but you actually wouldn't be able to measure functional residual capacity. You could estimate it, but you couldn't directly measure it. And then total lung capacity, you wouldn't be measuring with spirometry either. But again, you could estimate it based on someone's vital capacity. All right, so that's spirometry. So the second chart gives you a chance to go through it again. So what I encourage you to do is pause the video now and go through this new chart and walk through it and see if you can sort of explain it to yourself and act it out as you breathe it. So here's your shallow breathing, your normal breathing, and then you blow out as much as you can. Normal breathing, normal breathing in as much as you can. Normal breathing in. Out. Sorry, no, I was right in the first place. In, out. And so then the yellows are our volumes, and then our purples over here are our capacities. So try to walk through those. The last thing we'll cover in this video is this. It's a little small, and it's small because it's not that important. I'm not going to ask you the details of the difference, like this down here, present predicted vital capacity, all these calculations. I'm not going to ask those at all. Here's what I want you to just understand is that male and female respiratory volumes are different, and they're different for a couple reasons. Actually, it's really fundamentally one reason. Essentially, now there's sex differences and there's gender differences. In healthcare, we're trying to be a lot more cognizant of that differentiation. And sometimes people are, whenever they hear the term male and female, they in a health setting, they're starting to use the term gender now, like gender differences in health outcomes and things like that. It's not entirely accurate, though. Like, for example, in this discussion, what matters is whether there's testosterone present in high quantities. Because if there's in any individual, whether you call them male or call them female, if there's high testosterone levels in their body during skeletal development in puberty, they will tend to develop taller with large amounts of testosterone. The taller you are, the bigger your lungs are, and the larger your volumes. And so in general, we would call that a sex differentiation because it is referring to the biological differences that are the result of the presence of testosterone. We wouldn't call that necessarily a gender difference because that's more of a societal construct. And so this is real biology only here. And so it's really that testosterone question. Was there testosterone present during development of this individual, during puberty, essentially? And if there are, they're going to fall on this male spectrum, which is a lot bigger for two reasons. One, males are taller because of the testosterone. Taller you are, the larger the volume. The second one is testosterone also produces a larger muscle mass. And remember, inspiration is driven by skeletal muscle contraction. So if your accessory muscles are bigger and stronger, you are going to be able to breathe in more. If you can breathe in more, then your vital capacities are going to be larger. So the combination of those two factors work towards people with more muscle and people that are taller having much larger values here. And we tend to categorize that in academics as male versus female, and these are your average measurements here. And so take that into account. And the reason it's relevant is that if someone's sitting in front of you and they are phenotypically female and they are 6'7", you should still take into account that they may fall somewhere between these two numbers here. And so those two values, the height and their muscular development, are going to be the big things here. And these are just kind of your averages, taking the average male, the average female, and comparing them. But that's where you see the differences. Notice when you look through these numbers, 500 and 500, tidal volume doesn't take much muscle mass and doesn't use much of your lung volume. So there's actually no difference at rest. The differences emerge during the things that are dependent upon the size of your lungs and the muscular force that you can produce around your lungs. And inspiratory reserve is your biggest difference there. So that's just sort of an FYI thing. And it is important, though, as you measure these volumes, to understand that height and muscular development make a big difference in how much somebody can breathe. So if somebody's really short and skinny and doesn't have much muscle mass on them, then they're probably not going to have very large numbers. And you may not be alarmed if you get really low readings here. But if somebody's super muscular and 6'5", and you're getting really low readings, you should be much more suspicious of that. So those are basically all of those terms. So the percent predicted vital capacity, I'm not going to ask you to calculate those. So I will delete that off of your list. Everything else here, though, as far as how I'm going to ask them on quizzes, I might give you a table, just like this one, and ask you to label it. So be familiar with interpreting these charts. So sorry, not a table, a chart. I might give you an unlabeled chart, so make sure you can do that. I probably will give you at least one of those. And then I also might give you someone's vital capacity, their tidal volume, and their inspiratory reserve. And I want you to be able to do the basic math to calculate it. It won't be super tricky. It'll just be addition or subtraction. And that's the only numbers-based thing. As far as memorizing these numbers, here's the numbers that I want you to actually know. Tidal volume, I want you to know is 500. You should get that plus or minus 50 milliliters. Inspiratory reserve, you could remember it in your head as about 3,000. Expiratory reserve, remember it as somewhere between 1,000 and 1,500. I mean, 1,200, yes, that would be best if you remembered that. But if you miss it by 100 or 200 to either side, that'll be fine for our purposes. And then total lung capacity, I do want you to know that in a healthy individual, probably male on the spectrum, would be 6,000 milliliters for total lung capacity. And so know those numbers up here. These numbers down here, I am not as concerned that you will know. You may end up calculating them, though, because you might just calculate the vital capacity when I give you the components of vital capacity. So these are the numbers to really focus on up here, but again, they don't have to be perfectly remembered. And we will do a separate video on forced expiratory volume and this topic in here, because this is not spirometry in the same way that what we are talking about here is. So we'll do a little short video on that.